Hey guys, my name is Boris and I'm a computer engineering bachelor student at the Technical University of Berlin. And on this channel I want to talk about things that I've learned and might bring you value, general educational topics and lifestyle ones. Today I'll make the next bachelor thesis update video, as you could have probably guessed from the title. In the last video, so part 1 of these updates, I talked about setting up the Jetson, the Ria Rosnov repo and the Turtlebot. And I also talked about the initial struggles. We also already managed to get the Turtlebot to go from A to B with the default local planner called DWA. So I recommend watching the first part as well. So the next step was to get the other classical planners called TEB and MPC also to run on the Turtlebot. Now those two also work on top of MoveBase and also use the cost maps. Basically said, I had to look at the cost map parameters, but more importantly at the additional local planner parameters. TB and MPC are the local planners. And adjust them, or rather play around with them. For example, an easy and intuitive one would be the robot radius that had to be changed. In the sim we used 0.3 meters, but the Turtlebot is 0.105 and more. Here you can see my little arena and an obstacle that was not mapped previously. You can also see the map in Orvis and what the robot sees. Those red dots are the laser scan data and this little part here is the sleeping Pikachu. So this is the MPC planner, for example. It doesn't look that different from DWA and works quite well, although it sometimes does decide to drive against walls. Then there is TB, and yeah, something is going wrong with this one and I can't figure out what it is. The planner lets the robot drive into walls, doesn't move at all, and just does silly stuff. But I will soon get in touch with another master student working on this project. He wrote his own TEB planner and apparently that works pretty well. So let's see how that will turn out. So the 3 classical planners or model-based planners are basically done. Now come the real new planners, the deep reinforcement learning agents that we have trained ourselves. Other students and especially my supervisor worked on designing the custom environment. I will make a video where I explain the work behind my bachelor thesis, so if you don't know much about deep reinforcement learning and OpenAI Gym, please bear with me. But why are DRL agents better? Well, simply said, they are faster and perform better in highly dynamic systems, meaning in systems where there are a lot of people or other robots driving around and moving fast. Classical model-based planners tend to struggle there, but there of course are some issues with the deep reinforcement learning agents. For example, one is that they don't perform very well when the goal is far away. So about 2 meters or more away. That's why another student implemented a lot of fancy stuff to help with that. He even implemented his own global path algorithm based on A star, his own local planner, but most importantly also an algorithm that takes the global path and selects a sub-goal that is 2 meters away from the agent. We call it the spatial horizon algorithm and it's basically 20 to 30 lines of code and it's really simple. We take the agent, more or less draw a circle around him and select the intersection of the circle with the global path that is closest to the final goal as our sub-goal. This way the sub-goal always stays 2 meters away from the robot. So from all of this fancy code, I only needed the spatial horizon algorithm as a node that then publishes the sub-goal. So I wrote my own node in C++, took the spatial horizon code and added all the additional necessary components. For example, I still needed a global path and, as mentioned, the previous code searched for one itself and didn't use MoveBase. So that's what I did. I took MoveBase and used the service make plan to get the global path. Now it looks something like this. You see it's only the global path and the pink circle is the sub-goal that always moves with the robot. Well, what's the issue at the moment? When starting the deep reinforcement learning agent with the real robot, nothing happens. I think I've found an issue with the observation collector that is necessary for the reward. Again, if you don't know much about deep reinforcement learning and OpenAI Gym, you should be still able to follow along. So this observation collector subscribes to the ODOM and to the scan topic to collect the observations and determine what's happening around the world. But it wants ODOM and scan, or the data it's receiving, to be synced, and apparently it is not. At least that's what I think at the moment. Next, for training and evaluation purposes, the code for running the agent has a loop that goes through several agents other students have trained, and they have scripted scenarios with a predefined starting point and goal and several dynamic objects. In this case, the scenario here is not really made for this map, but you get the point. I just want one selected agent to go to the goal when I set one. I tried a few things. For example, I wanted to write a node that starts the agent as a callback for the goal topic, meaning that when a goal is set, my node that is subscribed to the goal topic starts the agent, and then lets the robot or the agent move to the goal. That didn't work quite well because another node is started by my run agent script, and they somehow interfere with each other, and it doesn't work out really well. So I just start the script manually, not as a ROS node. Again, the script itself on a deeper level starts a node and they interfere. In this script, the agent is in a while true loop and waits for a goal, which works fine, but he still performs random actions, so moves around his current position while waiting. This isn't that big of an issue, but it has to be fixed as well. Another little concern of mine is that the robot was trained with a radius of 0.3 meters, and as mentioned, the real turtlebot is 0.105. But let's see how the real robot behaves when I actually get the agents to run on it. It can very much happen that once I've uploaded this video, I find solutions to the issues and fix the bugs and have a better understanding of what is happening. But then I would think to myself, wow, now I've talked so much nonsense and everybody will think that I'm stupid or something like that. But that's the process of learning through errors and learning by doing. You try something and you'll see how it works and you will learn through that. And doesn't deep reinforcement learning do something similar? But yeah, that was my update and is my current status. I feel much better now. I have a better understanding of ROS, the navigation stack, and I think I have a fairly good understanding of how deep reinforcement learning works and how this script and the code works. But I will have to invest more time into the latter. I think my supervisor thinks similarly because in the last meeting we had, he also told me that he has the feeling that I have a good understanding and I know where to look for the bugs. So I hope you found this video interesting and enjoyed watching it and following along my process. If so, feel free to leave a like and subscribe if you want to see more content. If you want to see the first part of this update video, you can click up there. And with that said, as always, thank you very much for watching, and I'll see you guys in the next one. Bye!